Today we're going to be looking at direct variation, and this is typically used with a word problem. So first we're going to look at the word problem, and then we're going to describe how it is direct variation. So in this example, a caterer charges $30 per person for a meal. We want to complete the table, make a graph, and make the equation. So the first thing that you're going to do is to make the table. To do this, you first have to determine which is the dependent variable and which is the independent variable. To be able to do that, you need to know what the two variables are. So what you want to do is try to find the rate of change in the problem. So the rate of change can be identified with typically the word per. So they charge $30 per person, and that is the rate of change. Now within the rate of change, there are two variables. So in this example, the first variable would be the amount of money, which is the dollars, and the second variable would be the number of people. When looking at the two variables, to find out which one's dependent and which one's independent, you need to ask yourself, does the amount of money depend on the number of people, or does the number of people depend on the amount of money? So in this case, the amount of money depends on the number of people. So the amount of money is your dependent variable. And the number of people is your dependent variable. So the independent variable, this is independent variable. So the amount of money depends on the number of people. So the independent variable goes in the first column of the table. So this would be number of people. So you don't just want to write people. You have to include the units. So it would be number of people. And in the second column would be the dependent variable, which would be the cost of the catering service, and the units would be dollars. So that's how you set up your table. You pick some values of the independent variable to go into the column. In this case, they're given. And now what you do is you figure out what each of those costs would be for the number of people. So it's $30 for each person. So if there's 0 people, it's $30 times 0 people, which is $30. You don't need to put the dollar sign here because we've already put the dollar sign at the top of the column, which means all of these are going to be in dollars. If there's 5 people, it's $30 times 5 people, which is $150. If there's 10 people, 30 times 10 is 300. 15 people, 30 times 15 is 450. If there is 20 people, 30 times 20 is $600. 25 people, 30 times 25 is $750. And if there's 30 people, 30 times 30 is 900 people. So in the table, the independent variable goes in the first column and the dependent variable goes in the second column. When you go to make a graph, the independent variable will go on the horizontal axis. So this will be number of people. And you make your scale, so we need to go up to 30. So I'm going to go 5 people for every 2 boxes. And the dependent variable will go on the vertical axis. So this will be the cost in dollars. And my scale, I'm going to make 2 boxes to be $200. And the title of the graph should always be the dependent variable, which is the cost, versus the independent variable, which is number of people. Now we plot these points. For 0 people, it costs $0. For 5 people, it will cost $1.50. For 10 people, $300. For 15 people, $4.50. For 20 people, $600. For 25 people, $7.50. And for 30 people, $900. And now you're going to join all of those points with a straight line. And that's how you make your graph. So, independent variable on the x-axis or the horizontal, dependent variable on the y-axis or the vertical. And now to make the equation. So the first thing you're going to be needing to do is to do what's called defining your variables. So basically we're going to pick a letter to represent the number of people and a letter to represent the cost. So we can say let P represent the number of people, and then we can say let C represent the cost. So when you make these let statements, you pick a letter to represent each of the 2 variables, and you need to include the units as well. And the way the equation works is you start with the dependent variable, and that is equal to the rate of change, which is 30. That's the rate of change. And it's being multiplied by the independent variable. And what that basically is saying is that the cost we found over here, to find the cost, we took $30, which is the rate of change, and multiplied it by the number of people, which is what we did over here. So what this is saying is that the cost, which is C, is $30 times the number of people. So in a direct variation, that is how you make a table, a graph, and an equation. And when you make the graph, please make sure you use graph paper. So a couple things we want to point out is what is a direct variation? So a direct variation is a linear relationship which produces a perfect correlation, which means the line goes through all the points, and the graph starts at 0, 0, which means there's no initial value. So, and I just realized I made a mistake up here. Silly me. $30 times 0 is 0. So the fact that the initial value is 0 means that when the independent variable is 0, the dependent variable is 0 as well. And that is shown here on the graph, that the graph starts at the origin. So the next thing is you want to remember that the rate of change is the value in the problem that refers to the value of the independent variable per the dependent variable, which is what we did up here. So when you look for that statement that says something per something, that's the rate of change. So just like a scatter plot, the independent variable is the first column of the table, and it goes on the horizontal axis on the graph. The dependent variable is in the second column, and it goes on the vertical axis on the graph. And the title is the dependent variable versus the independent variable. To make an equation, you use variables and letters to represent the dependent and independent variable. These are called let statements. And the equation is in the form D equals M times I. The D represents the dependent variable. The M is representing the rate of change, and the I is representing the independent variable.